We finished discussing the overall development process for your Java programs. Let's see exactly how you can start writing one. So the simplest components you can include in your program is called a literal, which is a constant value, meaning that whatever you write is whatever it is. And then it can appear directly in a program. Let's see the kinds of literals we have. So the first one we got a character literal. It's going to be exactly one single character that's enclosed within a pair of single quotes. For example, you can see we got a single character A. We got a single character for the number 1. We got a single character for star. And also we got a single character for opening parenthesis. And now we also got a single character of empty space. And remember, you need to have exactly one character inside the single quotes. So can you have two spaces, for example, right? So let me see, show you what I meant. So now over here, can you say I got single quotes, I got one empty space? Can I just put another empty space over here and put a single quote? No, you cannot, right? Because you gotta have exactly one character inside a pair of single quotes. Remember, okay, for the character literal. Okay, and then the second one is more like a generalization of character literals. We call it string literals. You can think about it's basically a sequence of characters. You can have either 0 character or more, right? 0 character is actually okay. So now let's take a look. So a possibly empty sequence of characters enclosed within a pair of double quotes. So the way the way we distinguish between character literals and also string literal is by seeing what quotes you're using. So now you can see we got empty string over here, whereas empty character literal is not allowed, right? Notice the difference. And then we got a single character that's inside the string. We got more than one character that's in the string. And also we got just empty space over here. You can see this one here is similar to this one over here. However, there are different types. You can think about this empty space over here is a character literal, and this empty space over here is a string literal. Okay, so let's just let me summarize some important points for you. Okay, so we know that, for example, if you don't have any thing inside, this will also not be okay for a character literal. You got to be exactly one, and then you can have empty space. You can have just one empty space, and you can also have maybe a string literal that also contains a single space over here. However, this is a character. And this is a string. Even though they look the same when you print them out to the console, but they're different types, right? That's really important to notice. And the third one, we got integer literal. That's very easy. We simply got digits. We can get positive numbers over here, or you can get 0, or you can get a negative number by using the negative sign. Think about it's like a unary operator for applying the negative sign. Okay? I'll talk about operator in just a moment. Okay, and also we got floating points. Floating point got two parts. You got integral part, and also you got a fractional part. So how do you write it? You will be separated by a decimal points, or you can use the scientific notation. If you recall your high school math, you can also use the scientific notation. Let me show you some example here. So you can say 0.3334. So you can think about this part here is the integral part, which is 0. And this part here is the fractional part. They're separated by the decimal point, right? It's easy. And here you can see the fractional part is actually 0. But the integral part is actually larger than 0. Again, they're separated by decimal point, right? And etc. And it is also valid for you to write something like this. You can say I simply got dot over here to 3. So this is also considered as valid number literal. So here simply just implicit, it will be as if you simply put 0 over here. So that's also okay. Right? It's kind of up to you if you want to have that notation. All right, and this is the scientific notation over here, right? You can simply say +2. So that's denotes the positive exponents over here, right? And then the rest will just be, you just have to say E over here for the scientific notation. So if you need it, you can definitely use it. Okay, and then this will be just exponent where the exponent is actually negative. Right, so these are the literals you can write very easy. Just as a slide to summarize them. You got either character versus string versus integer versus floating point, right? You got the 4 kinds. All right, so now let's talk about operations. There are 3 relevant terms I would like to talk about. You really want to know what the difference is among them. So we say an operation refers to the process of applying an operator to its operand or operands. It can be plural. Let's see a little bit more elaboration on this definition over here. Let me use the example as well. Let's go over the principle and then we'll see example. Number 1, we say an operation consists of an operator, a single operator, and 1 or more operands. So depending on it's a unary operation or a binary operation. Let me show you what I meant. So now in terms of the operator, you can see here the multiplication over here, and also integer division. Okay, so the division will require some extra attention about how exactly it should be calculated, but I will do that a little bit later. But let's say we simply do division. And also this is like a less than. Also you got a greater than over here, right? Also you can say less than or equal to, greater than or equal to. So these simply correspond to what you learn in your math. And also larger than or equal to over here. So these are the operators, which I circle in blue. So now operator over here, either the operator is applicable to a single operand or it's applicable to 2 operands. So in this case, you can see these over here, 1, 2, 3, and also 4. So all of these are so-called binary operators. Binary operators. Meaning that they each one of them will need 2 operands. For example, you can see operands. So I'm going to use a highlighter, operands over here. So you can see for multiplication, you got 2 operands over here. For division, you got 2 operands over here. And for less than, you got 2 operands. For larger than or equal to, you also got 2 operands over here. We're going to learn about something called logical operator next week when we talk about Boolean data type. So just want to mention very quickly. So for Boolean operations, they are also binary, mostly. So for example, you got ampersand means a conjunction or simply and. And also you got vertical bar. So they simply means disjunction. I'll talk about how they are supposed to be manipulated next week when we talk about if statements. Okay, so here, so we talk about binary operators. Do we have any unary operators? Yes, we do. Okay, and let's be a little bit. Let me say a little bit more. The multiplication and also integer division, we'll say they are binary numerical operators. So also they are numerical. And also, the less than over here, even though it is binary, but it's called relational operator, right? So the less than and also everything over here, they are called relational. Okay, and then the ampersand and also vertical bar, they are also binary. So they are the binary logical operators. Okay. As I said, I'll talk about these 2 next week. Okay, so that's about the binary. What about unary? So here we got 2 examples for you. You can see here the negative sign and also exclamation mark over here. So they are unary. Unary operator. So now what's really the operand over here? You can think about for this particular unary operator, its operand is this entire expression over here. This is its operand, just a single one, right? It's not. So think about this particular negative sign we call overloaded. Okay, overloaded, which means it can be meant for 2 different meanings depending on the context. For example, example number 1. If you say -2, in this case, the minus is really meant to be a unary operator. On the other hand, another example here, if I say 2 minus 3, in that case, this minus over here is for numerical subtraction, but that one is a binary operator, right? Okay. Okay, hopefully that is not too challenging for you. And then, For this particular unary operator, it's actually not for manipulating numbers. It's actually for manipulating something called Boolean, either true or false. Again, I'll talk about more details next week. But for this one here, I just want to put a notes. Exclamation mark is actually simply means not. It is not the case. Okay. For those of you who is taking some logic course, this is the not, like a logical operator negation. This is the logic, and this is exclamation mark is the Java equivalence. Okay. So now for the not over here, you can see this is the operand over here. So it's going to, whatever this operand is going to evaluate to some value, which will be true or false, and then we're going to take the negation of that using the unary logical operator. Okay? So this was also unary operator. However, this one here is really logical. On the other hand, this unary operator is numerical. All right, hopefully so far so good. Okay, let's go to the second point. An operator has one or more applicable operands, as we just talked about, right? So let me just put one more note over here. So that's why we talk about either unary or binary. And also we talk about different, for different purposes. It could be numerical, it could be relational, or it could be logical, right? These are the three kinds of operators you will have to know in order to program for your application. The final points over here. An operation produces a value. Okay, it should be a value. Okay, so let me get rid of it. So that's definitely not type correct, right? Produces a value of certain type, right? I'll talk about data type a little bit later in the lecture, but an operation. So now think about over here. So operation includes both the operator and also the operands altogether. The fact that you try to apply the operator into its relevant operands, it will be an operation. Okay, so now you can see this is a numerical operation. Numerical operation. Okay, and then you can think about this is a relational operation. Relational, because I'm using a relational operator. And then this one over here, since I'm applying some logical operator, so the whole thing over here in the pink will be a logical operation. And sometimes people, rather than calling logical, they might simply say it's a Boolean operation. But I personally prefer to say logical because you may want to keep your terminology as formal as possible. Okay. All right. So that's really the difference between operator, operands, and also operation. Okay. So these are the three terms. They are really relevant, but you have to know the subtle difference between them. What role they really play in the context. All right. So let me go back to the slides. We just got a little bit more examples here for you. So we got numerical operations. The result are simply just numbers. And let's think about some example. So you can simply do addition. Okay, we simply add these two numbers together, and also division. So now I would like to talk about the division sign as I promised in greater details over here. So when we talk about division in Java, you have to see two cases depending on the kinds of operands you're using. Okay, so we'll talk about division. Okay, so we got case number 1, and we also got case number 2. Okay, so now let's say for case number 1, let me just give you some example here. If you simply got, for example, 23 divided by, let's say 4 over here, and then for case number 2, it can be 23.0 divided by 4. It could be 23 divided by 4.0. It could be 23.0 divided by 4.0. Okay, so let me just give you a little bit more explanation. So case 1 is to say both operands are strictly integers. Both operands are integers with no fractional part. And for case number 2, so this is to say at least one operand of the division is floating point, meaning that it has a fractional part. For example, you can see this one has a fractional part, this one has a fractional part, and both operands has the fractional part over here, right? So now, what would be the difference over here? Even though we are really using the division over here, and also let me just try to be careful with the color. So also division over here, but the kind of a result you will get is different. Okay. So now for case number 1, when both operands are simply integer, what you will get will be the integer quotients. Okay, so we know that 23 divided by 4, it will be 5 remaining, okay, let's see this. Let me see a little bit better. It will be 5 as a quotient with remainder. Three. Agree? So now how can we retrieve this 3 over here? 5 can be retrieved using this particular division. What about the remainder? We have to use another operator called the modulo operator. You will have to say over here 23 modulo 4 over here. So this one here is going to get a remainder. It's called modulo, but it can also get a remainder. Okay. For case number 1, let me just conclude by giving you one mathematical property, if you like. For case number 1, okay. So now let's say given 2 integers, let's say x and y. Let's say both x and y, they are simply just integer variables. I'll talk about variables later, but let's just simply assume x and y are simply just integers. Okay, so now I can say x is equal to, so here I say equal, I mean mathematical equality, right? Just equality. But let's just stick to Java here, just for avoid confusion. So in Java, if you want to compare values, you have to say equal. I will emphasize this a little bit later. Okay, but equal simply means equality. The value of x should be equal to the following. Okay, it will be equal to y multiplied by, what's the integer quotients? I can say x divided by y. Okay, and then plus x modulo y. So this will be some nice property here that will illustrate the combination of the modulo and the integer division and also integer modulo. Okay, let's just see one example here. So now let's see this. If I say 23 and also 4 over here, right? You can think about over here, let me use a different color here. Let's say use a green. So 23 and also 4. So 23 over here, and y is this is x, this is y. Okay, and then y will be 4, and then x divided by y, since both operands are integer, so we're going to get the quotients, and this part will be 5. And what about x modulo y? In this case, is going to give us the remainder, which is going to be 3. Okay, if you do the math, 4 times 5, 20, plus 3, 23, equal to x. So this will work for any arbitrary integers x and y. Okay, that's for case number 1. So what about case number 2? So for case number 2, in that case, at least one of the operands actually has a fractional part. Doesn't matter if the fractional part is 0 or not, as long as the fractional part is actually present. In that case, you wouldn't get a quotient anymore. So what you will get is you're going to get a precise result. Or you can say result with the precision, right? You can see in the slides. So now what will we get over here? So now over here, what we will get is going to be 5.75, I believe. You can check the math. All right. So now let me summarize what's happening over here. For division operator, in Java, you have to distinguish between case 1 and case 2. For case number 1, both operands are integers, in which case you're just going to get a quotient. Now, how do you get a remainder? You have to use another operator called the modulo or remainder operator. For case number 2, okay, so these two cases are mutually they are not overlapping, which means you cannot have both cases at the same time. No, you cannot either one, but not both. So now for case number 2, if you got at least one operand that's actually floating point, has some fractional part, in that case you're going to get a result with some precision. It's more like a mathematical result you will get, right? So now if you say 23.0 divided by 4, it's going to be 5.75. It's a very important operator or operation to understand. Okay? I'm pretty sure that will appear at some point in your programming test or your written test or your exam. All right. Hopefully that makes sense for now. And let's go back to the slides. Okay, so now we talk about division already. So here we just got another example. You can see this one here will get integer quotients because both operands are integers. And here, at least one operand is actually not integer, has a fractional part. In that case, they'll give you with precision. And this will be to get the integer remainder, right? All right. And then we got the unary operator, numerical operator, right? And then hopefully so far we talked about all the examples already. Okay, relational operations, that one is going to return either true or false. This is so-called a Boolean value, which again I will introduce that formally in the second week, next week, when we talk about selections. For example, you can say less than or equal to. In that case, apparently 3 less than or equal to 4 is true. And 5 less than 3, false. It's not the case. And also, if you want to compare equal, right? You don't really say a single equal. It's a very common confusion about Java is, if you want to do a value comparison, you must use double equal sign. If you only use a single equal sign, as we will see, that means variable assignments. So they're different. Okay, so now this will be simply false because 56 is not equal to 34 by its value. And finally, we got string concatenation, just another kind of operation. So now the plus over here again. So now something I will illustrate to you some tricky example, which I will see. We'll see. So now if you simply got string literal over here, you got string literal, an empty space. You also got another string literal if you use the plus. So now in this case, you can think about the plus sign over here is again overloaded, meaning that it can have different purposes depending on the context. In a context where both operands are simply just numbers, in that case plus will add up the numbers. But in the case where both operands or at least one operand is actually a string, in that case you're going to do concatenation, which means you can put the string together. So now you can see York followed by one space followed by university. So we're going to get York University, a single string literal. Okay, I will show you some further tricky example related to this a little bit later in the lecture. All right, finally, let's talk about something called data types.